Hi everyone, so here we are. We are finally on chapter 8 and you get to learn about chemical reactions. So we are going to start with writing chemical equations. So here is your generic form of a chemical equation. So remember that we have reactants that are on the left-hand side, okay, right here, and then we have products that are on the right-hand side of this arrow that's right there. Okay, so remember, you have the reactants, they're going to collide, they're going to rearrange themselves. Well, it's the atoms that are rearranging themselves, and then they're going to combine to make something new, which we call products. Okay, so reactants are on the left and products are on the right. So in order for a chemical reaction to take place, bonds are broken and new bonds are being formed, okay? And this is an example of what law? Does anybody remember? We talked about this in chapter 2. And so what we start out with is basically the same atoms that we're going to end up with. They're just rearranged to make something new, like a different compound, all right? So this is the law of conservation, okay? The law of conservation. And we're going to talk more about this. So here we have different ways that a chemical equation could be expressed. The first example here is in what we call a sentence, okay? A sentence. So iron reacts with oxygen to produce rust. Then we have an example of a word equation. So the elements, or I should say the reactants and the products, are still written out in words, but then we simplify it by adding plus signs and arrows. So then it makes it more clear what is on the reactant side and what is on the product side. Then we have what is called the skeleton equation. So in a skeleton equation, you have the symbols, okay, in chemical formulas, and skeleton means that the equation is not balanced yet. And that is something that we're going to focus on today, balancing equations. So I know you don't know what that is right now, but eventually you will. So once again, the reactants and the products are written out in their chemical formulas, okay? But the equation is not balanced yet. And then the last example we have is what is called a balanced chemical equation. So in a balanced chemical equation, we add these coefficients to balance out the atoms on both sides of the arrow, okay? And that is a more complete representation of a chemical equation. So the numbers that are in the front, they're in the same order, 4, 3, 2. Those are the ones that are right here, 4, 3, and 2. Okay, those are called coefficients. And so we add coefficients to balance equations, and that is something that I'm going to teach you in just a little bit. The last thing that I want to go over for today are these little symbols that you can add after each of your reactants and products. Okay, so after the substance, you see that it could be labeled with an S, a G, and that one happens to be an S. Okay, there are other symbols, and you can look in your textbook on page 206. So what these little symbols represent, they represent the state of matter. So what do you think S represents? Solid. Okay, that is correct, solid. A G would stand for gas. And then this is a solid. So in parentheses, we use that letter to tell us what the physical state is. Sometimes we might see an L. What do you think an L would stand for? That's right, liquid. And then another very common symbol after the substance would be AQ. Okay, AQ. AQ means aqueous, that the compound or element is aqueous. Aqueous means dissolved in water. Okay, dissolved in water. So those are all the things that you might see written after the chemical formulas. Okay? All right, so look what we have next. Okay, the last thing I want to talk about today are catalysts. All right, catalysts. Now, catalysts are basically used to speed up chemical reactions, okay? They are used to speed up chemical reactions. So if we have a chemical reaction, let's just say it's A plus B, that gives us AB. Catalysts are typically written above the arrow, okay? They are typically being or written above the arrow because they are not being used up in the reaction. So they're not written as a reactant or a product. We just write it above the arrow, all right? Now, in biology, you guys have learned about a biological catalyst. A biological catalyst, same idea. It would speed up chemical reactions, but these are chemical reactions that basically are found in your body, okay? So what biological catalyst did you learn in biology that would speed up chemical reactions? They are called enzymes, okay? Enzymes. Enzymes are found throughout many different body processes. Now, does anybody know what is the opposite of an enzyme? Okay, so this is something that would slow down a chemical reaction or even stop a chemical reaction. So I'm not quite sure if you have learned this term in biology or not, but it is called an inhibitor. Inhibitor. Okay, inhibitor. So inhibitors will slow reactions down, whereas catalysts will do the opposite. They actually speed the chemical reaction up. There are some chemical reactions that are so naturally slow, they might take hours or even days or weeks to happen. So that's why we would want to use a catalyst to speed it up. An inhibitor, we might want to use an inhibitor because not all chemical reactions are necessarily good. You know, they might produce a harmful product. So we might want to slow that process down or even stop the reaction from happening. So now I want to teach you how to balance equations. Okay, balance equations. So you can do this on your own piece of paper or find an empty spot on your notes somewhere. So balancing equations. This is a very important skill for you to learn. So make sure you really practice this, okay? All right, so let's start off with this chemical reaction. H2 plus O2 makes H2O. All right, makes H2O. So basically, remember all these things on the left side of the arrow, these are called reactants. On the right-hand side, we call these products. So the number of H's and O's have to match up on both sides of the arrow, okay? So I have to have the same number of H's and O's on the left side and on the right side so that our chemical reaction is balanced. Remember, this is the law of conservation, all right? So whatever amount of atoms we start out with, we're going to end up with the same amount of atoms on the other side. So there's a couple ways that you can do this. I usually teach students to place all of the elements in a chart. Now, you don't have to use the chart method. It's just one way to organize the information, and some people will develop their own way, okay? But I teach you by using a chart. All right, so what we're going to do is we're going to write down how many of each element, or atom, I should say, that we have on each side of the arrow. So on the left side, we have 2 H's. So I'm going to write that on the left side of the chart. And then over here on the right side, I also have 2 H's. So I'm going to write that on the right-hand side of the chart. Okay, now we take a look at the oxygen. There's 2 of them on the left. So we put that in the chart. And then over here on the right-hand side, we only have 1. Okay, so we can see that the H's are balanced. There's 2 on both sides. But then, look at our oxygens. We only have 1 right here that's on the right. So we need to make that 2 somehow. And when you balance these chemical reactions, you can only add numbers in the front. Okay, you can only add numbers in the front. You cannot change these subscripts. If you change these subscripts, then you're going to be changing the compound or the substance, and you don't want to do that. So I draw these little lines in the front as a reminder that that is the only place you can put a number, Okay, it is the only place that you can put a number, and they have to be whole numbers. All right, we like to have whole numbers there. So if we have 2 oxygens on the left and only 1 on the right, somehow we have to make this 2. So to make that 2, then we have to put a 2 in the front of the water. By putting a 2 in front of the water, it multiplies through, okay? So it's going to double everything here. So then, by adding a coefficient, it changes our H's. It's going to change our H's on this side. 2 times 2 is 4. It's going to change it to 4, okay? So then I'm going to cross that out, and I'm going to put a 4. But by adding the 2 in the front, it gives us the 2 that we wanted for the oxygen. So I change that one to 2. So you can see by adding the 2 here, it changed the H's, so then I have to go to the other side to balance it out to change these H's to equal 4. So then, what number do you think I should put in the front there to make that equal 4? A 2. So I'll put a 2 there, because then 2 times 2 gives me 4. So I'll change that to a 4. So now you can see that I have 4 H's on the left, 4 H's on the right, 2 O's on the left, and 2 O's on the right. So you can see that now this equation is balanced. Notice right here for the oxygen that I did not put a number there. Okay, so I did not put a number there. It is implied a 1. So if it's a 1, we really don't write a 1. So we would say that the answer would be 2, 1, 2. We would list the coefficients in order. All right? Let's do another example. And this one I want you to try it all by yourself. So let's see, KClO3 gives us KCl plus O2. All right, so I want you to balance this all by yourself, pause the video, and then see if you get it right, okay? So the first thing that you should do is list all of the elements that are in the chemical reaction and do a chart, okay? So let's write down how many we have of each thing on each side of the arrow. So we have 1K there, so that's 1. We have 1 Cl, and we have 3 O's. Okay, let's go to the right-hand side. 1K, 1 Cl, and then on this side, we have 2 O's. All right, so we can see that the K's look good, 1 on each side. The Cl's look good, but then look at here, our oxygens. We have to balance out the oxygens. So once again, when you balance an equation, we can only add numbers in the front. Okay, we can only add numbers in the front, which we call coefficients. So by looking at the oxygen here, 3 and 2. Well, what's a common multiple between 3 and 2? 6, right? 6. So to make this one 6, we have to put a 2 in the front. So that 2 times 3, right? That will give us 6. And we go to the other side to make this 6. We are going to put a 3 in the front because 3 times 2 is 6. So then that makes that 6. But then don't forget, by adding a coefficient here, it's going to change the K and the Cl also because it multiplies through. So that means then we have 2 Ks and 2 Cls. All right? So when we balance that out, the oxygens look good now. But then now, look, we have to go fix the Ks and the Cls. We need 2 of those on the right-hand side. And so if we put a 2 in the front, right there, don't forget, it multiplies through. So then that will give us 2 Ks and 2 Cls. So now you can see we have 2 and 2, 2 Cls, 2 Cls, 6 Os, and 6 Os on each side. So now this chemical equation is balanced. So then we would say that this one is 2, 2, 3. Let's do one last example. All right, once again, we can only add numbers in the front. And this time, for your chart, you'll do Ag. Okay, we're going to list all of the elements. So we have Ag, we have magnesium. Now I'm going to teach you a shortcut here. See how we have nitrate, which is a polyatomic ion, and the polyatomic ion stays together on the product side. So a shortcut would be to list the entire polyatomic ion in your chart. And you can only do that if the polyatomic ion stays together on the product side. If the polyatomic ion breaks apart, then you have to do the N's and O's separately. Okay, you would have to do the N's and O's separately. Now, do you have to put the whole entire polyatomic ion in the chart? No. If you want to do N's separately and the O's separately, you'll still get the right answer. Okay, so this is just a little shortcut. All right, so let's go ahead and list how many we have on each side. So 1 silver, 1 magnesium, and then I see the 2 here on the outside of the parentheses, so that means that I have 2 of the nitrates. On the right hand side, 1 silver, 1 magnesium, and then you can see that I only have 1 set of nitrate there. Okay, so our silver looks good, 1 on each side. Magnesium looks good, but our nitrates need to be balanced. So we need to make this one a 2 somehow. Once again, you can only add numbers in the front. So then I'm going to put a 2 in the front. So notice that that changes the silvers to 2. And then that will give us the 2 nitrates that we were looking for. Okay, so the nitrates look good now, but by changing the silvers to 2, I have to go to this side and make this one 2, so I'm going to do that by putting a 2 in the front. And then now my silvers look good, and magnesium is balanced also. All right, so this one would be 2, 1, 2, 1. And that is it. That is how you balance equations.